this video, we're going to talk about how to graph quadratic functions. So a polynomial function of degree n is the following form, where n is a non-negative integer, meaning the exponential powers. A0 through an are real numbers, and a of n, or the leading coefficient, is not equal to 0. So an example of a polynomial function x of degree n . All the coefficients and constants are real numbers. All the exponent powers are non-negative numbers. Now, we'll talk more about polynomial functions in later videos. Specifically, I want to talk about quadratic functions that are special types of polynomial functions where the degree is 2. And in the general form that I have here, we do not want the leading coefficient to be 0. If the leading coefficient is 0, then you're left with bx plus c. Well, bx plus c is a linear function, meaning not quadratic. So we want to make sure the leading coefficient is not 0. And we know the graph for this picture is a parabola. The vertex is the high or the low point on a parabola, and the axis of symmetry is a line that splits the parabola into 2 equal parts and intersects the parabola at the vertex. So I've given 2 examples of quadratic functions. On the picture to the left, the vertex is the low point. The picture on the right, the vertex is the high point. Okay? And in blue is my axis of symmetry. All right, now, one way to graph quadratic functions is to be able to determine the vertex, determine x and y intercepts, and then determine the free point using your axis of symmetry. Now, recall the axis of symmetry is x equal to negative b over 2a. The axis of symmetry is also the x coordinate for the vertex. So once you know what the x coordinate for the vertex is, all I need to do is plug that value into the function to determine the range value for the vertex. Okay, so I want to graph this quadratic function by finding the vertex, x and y intercepts, and the free point. All right, let's start with the vertex. Now again, before I can know what the vertex is going to be, I need to determine what the axis of symmetry is going to be. All right, so my axis of symmetry is x equal to negative b over 2a. Well, b in this case is 4, and a is negative 1. So negative 4 divided by negative 2 is 2. Plug 2 into the quadratic function. Well, negative 4 plus 8 minus 1 is 3. So the vertex is 2, 3. Make sure you label precisely what the vertex is, because remember, that is an ordered pair. Okay, so now I want to determine my x and y intercepts. Okay. Remember, x-intercepts, we know g of x is 0. So I'm going to replace g of x with 0. And I want to solve this quadratic equation. So I'm going to divide by negative 1 to get rid of the negative as the leading coefficient. And clearly this is not factorable. There are no factors of 1 that add up to be negative 4. So you have 2 options, quadratic formula or completing the square. Since we're going to be doing a lot with completing the square in this video, I'm going to complete the square here. So what am I going to do with completing the square? Half of negative 4, that's negative 2. And negative 2 squared is 4. So here I'm going to add 4. And on the outside, I'm going to subtract 4. Remember, 4 minus 4 is 0. That's not going to change my equation. Okay. All right, so x squared minus 4x plus 4, that factors as x minus 2 squared. And 1 minus 4 is negative 3. Now, I should be able to solve for this. So add 3. Take the square root of both sides. And add 2. So, what does that mean? I've got 2 plus the square root of 3 and 2 minus the square root of 3. Well, if you put 2 plus the square root of 3 into a calculator, that's approximately 3 7/10. If you put 2 minus the square root of 3 in, that's approximately 3/10. So I can write that as an ordered pair. And write that as an ordered pair. So those are my two x-intercepts, approximately. Okay. All right, so my y-intercept, we know x is 0. I'm going to plug in 0 for x. Now again, go back to the original equation for this. Okay? When I go back and plug that in, okay, I should end up having -1. So that is 0, -1. Okay. All right, so let's go back and plot these 4 points. I'll label my slashes as such. Okay. So what? I have a vertex 2, 3. I have a y-intercept 0, -1. One of my x-coordinates is 3/10 and 0, so that's about there. And the other one's about 3 7/10. Now, I'm going to draw my axis of symmetry here. Now, notice on the left-hand side, I have 2 points to the left of the axis of symmetry, and I only have 1 point to the right of the axis of symmetry. I'd like to have an even number of points on both sides. So I would like to find a point that is symmetrical to the y-intercept. Now, easy to do. From the y-intercept to the axis of symmetry is 2. I'm going to go 2 in the other direction. And that leaves me with this particular point here. That point is what is called the free point. Okay. And the free point in this particular case is 4 and -1. Now that I have enough points, I can graph this. Okay. And again, that should be smooth, not pointed. Okay. There's my sketch for this function. Now again, this is exactly how I would teach this to my 051 class. But for college algebra, I'm going to show a different way to do this. Okay. We would like to be able to use transformations because we've talked about transformations prior to in this course. Okay. Well, the quadratic function in vertex form is f of x is equal to a times a quantity x minus h squared plus k, where h comma k is the vertex. Okay. Now, right now, this is in general form. I want to get this to vertex form. Okay. How am I going to get that quadratic function equation into vertex form? We're going to be completing the square. Okay. So let me rewrite. Right. So it's going to be written as this. So remember, in order to complete the square, I'm going to do what? Half of 4, which is 2, and 2 squared is equal to 4. So I'm going to add 4 and subtract 4 here. Now, this factors as x plus 2 squared, and then 5 minus 4 is a positive 1. Now I'm in vertex form. So now we should have absolutely no problems graphing this using transformations. So if you recall, we're always going to start with the parent function. Well, because this is quadratic functions, it'll be x squared here. So what's next? I need to take care of the plus 2 on the inside. Which direction is this going to go? That goes to the left. And now I have to deal with plus 1. Which direction is that going to go? That'll go up. Okay, so let me label my axes. Okay. All right, so first off, I'll graph the parabola. Okay, so x plus 2 squared. I need to move everything to the left, 2, so I will do that. Once that's done, I'm going to move up 1 from the blue. So my vertex will be there. So the red is my final transform function. So again, completing the square gets it into vertex form so that I could use transformations to graph this. Now, I've graphed this on Desmos. As you can tell here, and my red, they are similar finishing spots and similar graphs. Okay, so we have one other one I want to graph by transformations. Okay. So, the very first thing I would like to be able to do for this, okay, is to have this into vertex form, which means I have to complete the square. So, I'm going to rewrite. Now, I'm going to put the first two terms in parentheses. And now what I'm going to do is I'm going to factor out a -2 from the first two terms. So I have this and this, and now I'm going to have this. So I can help myself to completing the square for this. So again, what do? I take half of -2, which is -1, and then square it. That's a +1. That's going to be a 1. Now, be very, very careful here. Notice I have 1 times -2 because you got to distribute the -2 to each term here. That is -2. So the opposite of -2 is +2. So I'm going to add 2 here. Not subtract 1. I'm going to add 2 because -2 times 1 is -2. I'm going to add the opposite, which is +2 to the others out to the outside. Okay, now finish completing the square here. Okay, now I'm in vertex form for this. All right, so let me list out my transformations as done earlier. Again, start with the parent function. Take care of the -1. Which direction is that going to go? That'll go to the right. All right, so now I'm going to take care of the negative. And that should reflect across the x-axis. Take care of the 2 now. And then the last thing I want to do is to add 3. Okay, so let me label my slashes as such. Okay, so again, first thing I'm going to do is graph the original. Okay, so in blue then, I'm going to move everything to the right. 1. I'm going to reflect it across the x-axis. All right, so now the 2, remember, that vertically stretches, but we know that's going to look narrower. And then the narrower graph, I'm going to move up 3. Okay, so let's compare this to Desmos then. As you can see, this in the red, okay, and mine in the final blue here, similar, same vertex, same shape, pretty close.